Well, part three. This hasn't happened in a long time, but the video cut off. But guess what? This time I'm almost done. I'm on the last problem. So it worked out. The other problem just got on there, I believe. So this is number letter E. This is the most important one. No, I'm sorry. This is F. F. It's the most important one. And it'll be a lot like the ones I just showed you. But anyway, just as a summary, think about this in terms of the equation. Anytime you see an equation in any chapter, molarity chapter, in the gram stoichiometry chapter, in the ones coming up ahead, this always gives you the mole to mole ratio: 2 moles of SO3 to 1 mole of O2, 1 mole of O2 to 2 moles, 2 to 1, 2 to 2, 2 to 2. They're all mole to mole. However, in the gas law chapter, if all of this was done in the same container, it could be in a container with what they call a movable piston, or it could be in a container with a rigid container. It doesn't matter. If they're in the same container, that means they're under the same conditions of pressure and temperature. So you can also let these numbers be not just the mole to mole ratio, but for gases it can be the volume to volume, and even in this one you'll see the pressure to pressure ratio. So 2 to 1 to 2 could be the pressure to pressure ratios, or 2 to 1 to 2 could be the liter to liter ratio, or the mole ratio. Okay, this one says oxygen and sulfur dioxide are contained in a flask. Okay, so it has a rigid container. The sulfur dioxide has a partial pressure of 4.50 atmospheres. So sulfur dioxide in a flask. Maybe I'll draw a little. Well, this is not really a flask, it's like a container, but oh well. It could be a flask as well. All right, so you have SO2, and its pressure is 4.50. And the oxygen has a partial pressure of 1.50. So you have SO2 in there, and you have O2 in there. And we know the pressure of the O2, and we know the pressure of the SO2. All right, you have a lot more SO2. Because remember, just like putting air in a tire, higher pressure would tell you you've got more moles of gas. Then it says, okay, the two are allowed to react. And there's the reaction. Calculate the partial pressures of SO2 and O2 after the reaction is complete. I think by now you kind of get it. I've been doing this on the other sample problems, even that one that was a little bit messed up. So what you do is, obviously, you can use pressure to pressure ratio. If they had given you the temperature and the volume of the container, you wouldn't even need them. The shortcut is pressure to pressure. So to find the pressure, I think I've already done this, haven't I? Like I'm doing the same problem again, but this time with pressures. So there is a limiting reagent, obviously, because you have two initial reactants. So just do the shortcut, 4.50 divided by 2. Now, only do this shortcut if they don't ask you to justify. If they say justify your answer, then you got to make two calculations. Convert this one, SO2 to O2 atmospheres, convert O2 to SO2 atmospheres, and say, well, this is a limiting reagent because you have this pressure of gas available, but this pressure is required. You got to make a statement if they ask you to justify. They didn't ask that here. So in fact, they don't when they say justify, then you know it's a limiting reagent. In this one, you don't even know, except we've been doing a lot of problems. If they give you two reactants, it's going to have to be a limiting reagent there. So 4.50 divided by 2 is 1.25. No, 2.25, sorry. And 1.50 divided by 1 is 1.50. So this time the O2 will be the limiting reagent. Now you can do it the other way if you wanted to, but you know. And by the way, okay, so I can do this now on O2. I've got 1.50 atmospheres of O2. What will be, it says, calculate the pressures of SO2 and O2 after the reaction is complete. Well, first of all, O2 is a limiting reactant. So how much O2 are you going to have at the end of the reaction? None. So it'll be 0. So you might have to say O2, the pressure of O2 final will equal 0. O2 is used up. is used up limiting reactant. Now, they didn't ask you to write that down, but if you just put 0, you'd be okay. But that just explains it. So we know the oxygen is going to be 0. All right, I'll erase that now, okay? Now, but for the pressure of the, it says, what's the pressure of the SO2? Aha, after the reaction. So, atmospheres of O2 will go to atmospheres of SO2. And it says for every one, you need 2 of those. So what I'm calculating right now is 3.00 atmospheres of SO3 are required. You know, this is kind of like, you do have to do a little bit here. That's how many moles of SO2 are required in the reaction. Now, how much are you going to have at the end? Well, you have excess. So at the end, does it say at the end or complete at completion at whatever? At the end of the experiment, whatever. 4.50 atmospheres available of SO2 were available, minus 3.00 atmospheres SO2 required. So 1.50 atmospheres of SO2 excess. So at the end, so the final answer, well, pressure of O2 will equal 0. Final. If they were to ask what was the initial, well, they gave the initial pressure. I wouldn't ask you that. But the final pressure of O2 was 0 because it's a limiting reagent. The final pressure of SO2 will be 1.50. And then the other question says, number 2, calculate. This is not what they would do in AP. I'll tell you what they would do in AP, but we'll do it. Calculate the partial pressure of the sulfur trioxide formed after the reaction is complete. So obviously we're going to have SO3. They wouldn't do that. They would just, the next question they would ask you is, what will the total pressure be at the end of the reaction? What will the total pressure be inside that flask? And so the total pressure will be the pressure of the oxygen, which is 0, plus the excess SO2, 1.50, plus the pressure of the SO3. That will be your total pressure. That's really what they would ask you. So I should probably redo the question, rewrite it. But what I'll do is we still start with our limiting reagent. We're going to answer the question on the paper. But then I'm going to also just tell you what the real question is they would ask. Because they're not going to give you that many steps along the way. They're going to try to make you leap over to get the 5 on the question. All right, 1.50 atmospheres of O2. That's your limiting reagent. So we're going to use that to find atmospheres of SO3. So atmospheres of O2, atmospheres SO3, and it's going to be also 2-to-1 ratio. So 3 atmospheres of SO3. In the end, you'll have 3 atmospheres of SO3. 3.00 atm. So they didn't ask this question. So at the end of the reaction, that's part 2. You have 3 atmospheres of SO3. Your total pressure at the end of the reaction, they did not ask this, will be the pressure of O2 plus the pressure of SO2 plus the pressure of SO3, Dalton's law. So that will be 0 plus 1.50 plus 3. So that's going to be 4.50 atmospheres. Okay. I think you can do any stoichiometry problem now with gas laws. They're almost the same problem over and over again, aren't they? So I think this is the best one. But they could also ask you in terms of volume, or they could ask you in terms of, what was the other one I showed you? The other one, well, yeah, it could be. I mean, it wouldn't really be a gas problem, letter E, because you mainly find moles. At the end, you use PV and RT. All right, see you guys.